Hi friends, welcome to GMK tutorials. Now today we are going to discussing about the nMOS NOR gate realization. Before going to the nMOS NOR gate realization, let us recap the previous session, that is nothing but nMOS NAND gate realization. In this video, just we see the different types of the, that is nothing but we are taking the pull up transistor is nothing but a ZPU, this is nothing but a impedance of the corresponding, this is the pull up devices, pull down, it is nothing but pull down devices if you are connected in this fashion. So let us see the whether it is acting as a ungate realization or so this means the corresponding transistor is connected in this means this is always this output is always is in very high value. Because of this depletion mode is directly having some channel will be there in the manufacturing itself. No need of minimum voltage to maintain a channel between the source and terminal. Therefore, it produces a high voltage. Therefore, it presents as a always high output. That means in this consideration, whenever the corresponding AP voltage, let it be considered if the all input voltage is also zero means if you are treating like this, the corresponding all NMOS transistors are going to be in open circuit condition. Because of it act as a it's for zero input voltage, these NMOS transistors are going to be open circuit. Therefore, no direct path will be existing from this voltage to so from this to this one. No path will be there. So no path will be means that obviously that output maintains a high voltage. Moreover, these are connected in a series fashion. Any one of the one output is also open circuited. No path will be existing between the from output voltage to ground. Therefore, obviously high output maintains at the across the corresponding terminal. So in the last condition is nothing but in the NAND gate realization compulsory, which produces a high output whenever the all inputs are in activation. So that means when the input voltage, that means when the input voltage, that means let it be considered for NMOS transistor having a logic 1 will be there. That means high output will be there. High input is applied to the NMOS transistor. At that time, the corresponding NMOS transistors are going to be in a short circuit condition. Therefore, it acts as a short circuit path from VDD to, so that means this terminal, drain of the terminal to ground, there is a path will be there. That means whatever the high voltage will be there, that high voltage may be passing to the ground. Therefore, it leads to output voltage is equal to 0. So that means it satisfies the criteria, right? So if you are applying any one of the input is equal to both all inputs are 0 means that this NAND gates are act as a open circuit, no connection will be there, output is high, and 0 1 combination. Any one of the input is 0, that corresponding NMOS transistor act as an open circuit. At that time also no path will be there. Therefore, it maintains again high voltage. In the last consideration, whenever all the inputs are going to be in on condition, at that time all transistors of the pull down network, NMOS networks of NMOS transistors in the pull down network act as a short circuit path. Therefore, the corresponding output will be going to be discharging to zero voltage that satisfies the minimum NAND gate operation. So let us go for the so this is already we discussed the what is the minimum ZPU by ZPD ratio, that is nothing but 4:1 ratio is also discussed. Time delay is also increases. Coming to the NOR gate realization, so because of it is very important for the NOR gate realization point of view. So let us in the NOR gate realization. NOR gate realization. So NOR gate means what is the basic equation, basic truth table for the NOR gate realization. Let us see the. So మనం ఏదైనా ఒక గేట్ ని రియలైజ్ చేస్తున్నాం అంటే ఫస్ట్ ఆఫ్ ఆల్ we have to follow the basic rules. Then only we will come to the designing point. మనం ఒక NOR gate design చేస్తున్నాం means that what is the basic truth table? A, B and Y is equal to A plus B whole bar. Right? This is the complement of OR gate, right? 0 0 0 1 1 0 1 1. This is the criteria for OR gate. This output is 0 actually. For complement of this means 1 0 0 0. This is the minimum criteria, right? So from this diagram, what from this truth table, what it shows this means only whenever the corresponding two inputs are going to be 0, at that time only the output should be equal to 1, and in the remaining all consideration the corresponding gate produces a 0 output. So that means oka input అనేది compulsory, it maintains a if the all inputs are going to be 0 condition at the time, output should be equal to high condition quality. So from the basic from the previous diagram, I will use the same depletion mode is used as a pull-up network, but I can change the corresponding nMOS transistor. Previously ఇక్కడ యూస్ చేసిన ఈ nMOS transistor మనకి సిరీస్ ఫ్యాషన్ లో ఉన్నాయి. దీస్ సిరీస్ ఫ్యాషన్ లో ఉన్న ట్రాన్సిస్టర్స్ ని కానీ మనం parallel లో కనెక్ట్ చేసుకుంటే ఎనీ వన్ ఆఫ్ ది గేట్ ఆన్ కండిషన్ కోసం. దట్ ఈస్ ద basic criteria. That means this pull down network is going to be in parallel fashion. That pull up network is in the same fashion. So let it be see the circuit diagram for that one. So this is a depletion mode of nMOS transistor. I will represent like this. It is connected to VDD. So gate is also connected to source terminal. I will treat it as a output. In this consideration, previously we are connecting nMOS transistors are in a series fashion. Now we are connected in the form of a parallel. Okay. This is gate number 1. This is nothing but gate number 2. So if you are treating it in the same fashion, if you are taking a n gates like this, so these are all tied together. It is connected to the ground, right? This is a scenario, right? So we are taking the output across the corresponding terminal. So this is a fashion how we are how we are going to design the corresponding nMOS transistor. By using nMOS transistor, how to design the corresponding NOR gate. Let us see the operation here. So let us see the one by one input application. Suppose if you are this we know that generally it is a pull up network. This is nothing but a pull down network. This is nothing but a pull down network. So whenever this pulled up network is always on. So this output values is always in high position. So let us see the situation when the input voltage is 0 0 means that let us consider when the input is equal to 0 0 0, at the time all the nMOS transistors are going to be act as a open circuit. No path will be there from this point to the ground. ఇక్కడ నుంచి మనకి ground కి path అనేది లేదు. No path will be there. No path. So output should maintain a high value. Suppose any one of the input of the corresponding gate is in high condition. Okay, high value maintain just under. That means if you are applying the any one of the input is let it be considered one value. At that time one transistor is going to be short circuit. Therefore the path will be takes place in this direction. Output is equal to 0. That means it satisfies the criteria. Suppose if you are taking any one of the possibility, any one of the nMOS transistor in the pull down network is on condition, there is some path will be discharging path from V output to ground. Total output is equal to 0. So that is nothing but operation of the NOR gate as well as the designing of the NOR gate transistor. So compared to the NAND gate realization, it is very useful because of in case of the NAND gate realization, if the number of inputs are increases, obviously the delay time is also increases. Moreover, we need to maintain the 4:1 ratio of the NAND gate in case of the NAND realization. That is very difficult process. Coming to the NOR gate realization point of view, here we don't have any problem because of the area occupied by the nMOS NOR gate is reasonable because of pull up transistor geometrically is not affected by the pull down network. That means in case of the NOR gate realization, let us see the sum of the points. We know that generally this is a ratio, right? This pull up network size cannot be affected by this pull down network because of in case of the parallel network మనకి parallel network లో చూసుకున్నామంటే the resistance value is always same. That means this pull down network is all pull down networks nMOS transistors are in equal resistance value. That means it maintains a same resistance, that means same impedance value. So if you want to maintain the 4:1 ratio, obviously it is possible. Moreover, that's why the number of inputs in case of the NOR gate cannot be affected the 4:2 ratio of the corresponding network. Therefore, the size of the device is also very reasonable. The worst case delay of the NOR gate is also comparable to the corresponding inverter. Okay, so So from this conclusion, we can prefer always NOR gate compared to the NAND gate. Always prefer size is reasonable. Size is also reasonable. Always prefer always prefer nMOS NOR gate compared to nMOS NAND gate realization. So this is a conclusion because delay is also reduces. Moreover, the 4:2 by ratio is very easy. Maintaining 4:1 ratio is also possible also. Okay. Moreover, pull-up network cannot be affected by the number of inputs. Impedance of that means ZTU is not affected by number of input. That means if the number of inputs are increases, the impedance of the pull-up network is also not affected. These are the some of the very important points regarding the NOR gate realization, right? So it is very clear, I hope. Okay. Thank you guys. Thank you for watching GMK tutorials.